أهلا وسهلا فيكم ثواني من بدي. Testing, 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 testing. اوكي، بقينا شوي من بدي، نص دقيقة ان شاء الله من بدي. Okay, مساكم الله بالخير. How's everybody doing? So I'm gonna have to switch to English so everyone can enjoy this session today. And yeah, let's go through this. Okay, so hello everyone, my name is Ameen Altajer. I hope you're all well and sound. Today's session is gonna be called Exploring the Guts of TensorFlow, which is a very cool subject, let me tell you that. And it's actually one of my favorites. So yeah, let's go through this. So first things first, my name is Ameen Altajer. I'm currently a machine learning Google developer expert. And you can probably reach out to me if you want at ameenaltajer.com or at Ameen Altajer. Pretty accessible, always reachable. So whenever you have any questions spanning the tech, anything that has to do with security, machine learning, reverse engineering, game development as well, I'll be more than happy to help out. Now, you can always check out our work at INFINITEWARE.com if you're interested in the kind of machine learning products that we have. And I mean, you guys are super welcome to go there and enjoy the kind of products that we have. Some of our clients are here, as you can probably see. We have government, we have private sector, and we have a lot of people in between. And we also do have our own cool products within the AI space. So we created a machine learning based chatbot that allows people to go ahead and talk to this sort of chatbot in their own slang language. So this is pretty cool, and it's one of our best-selling products that we have. All right, cool. So let's get directly into it. So today's session is going to be about TensorFlow. So TensorFlow is a very cool product by Google, and it has a lot of details, a lot of specific features, and you're definitely not going to be able to cover all of it within one session. However, what we want to try to go and tackle today is a sort of a tour within the source code of TensorFlow. We want to go through it. We want to make sure that we understand the very important basic building blocks, let's say. And we're going to have a tour on the source code itself, and we're going to explore how to build it if we wanted to. And we're also going to go into some really cool details like interfacing with the C API if you want to build, let's say, tools or things on the side using the same TensorFlow foundation layers, And so, yeah, let's go through that. So in case you haven't got the chance to, to use TensorFlow, so TensorFlow is a very popular machine learning framework within the, again, machine learning community. And a lot of people use it to do really cool things, from GANs, generative adversarial networks, to regular, let's say, classification / regression supervised models. And a lot of people also use it for very cool things within the unsupervised space as well. So it's a very beautiful and a very high performant framework, honestly. Now here's the trick. A lot of people don't understand that TensorFlow is not only a machine learning library, it's actually much more. It's a as they likely call it, a numerical computation graph library. So it has a lot of things that you can do, that relies on gradient descent, and it's really beautiful. You can use it in so many aspects. However, the most popular use case as of today for TensorFlow is probably machine learning, and it has a lot of value within that space. So just remember, it's the flagship product for machine learning, under Google. And the beautiful thing as well is that it has a lot of, let's say, community support. A lot of people like me and like yourselves are interested in doing work within the space of machine learning, and so you get a plethora of choices. However, one of the really good ones that are available online today, free of charge as well, is TensorFlow. And so TensorFlow, just like what we said, is a numerical computational library. So even though we're going to use it for machine learning, we can also use it for other stuff if we wanted to. Okay. Now, the reason we call TensorFlow a graph engine, or a numerical library, basically, that is graph based, is because under the hood, what happens is when you build a machine learning model and you try to get those Lego parts, and basically cram them all together to build a model, you basically have a graph of some sort, and then in that graph that represents your neural network, you're basically trying to adjust the weights of the neural network if you have ever done any machine learning course. And then those weights and those biases, they're going to be shifted and they're going to change their values to get to that optimal level. So your machine learning model is going to work out as expected. And so just remember, in machine learning, the idea, or specifically within deep learning, the idea is very simple. You have a lot of inputs and you have a lot of outputs, and you're trying to train a system that can take it all the way from the input to the output without you explicitly writing the logic. Now, this is the ultimate goal for TensorFlow. You want to make it so smart that it can take you from the input to the output, and then you want it to build the logic on its own. Now, we do know that's not going to be logic, to be quite frank. So you don't have instructions just like what you do if you were a programmer. Now, if you're a programmer and you have a typical machine learning case, you will probably figure out what the issue is, and then you're going to try to build the actual code to get you from the input all the way to the output. And now we all do know that this is a very challenging process. You need somebody that's extremely good when it comes to understanding the tech requirements, the business requirements, and they have to have the ability to translate these requirements all the way to basically that tangible format that we call a program. Now, in machine learning, the idea is completely shifted. So you have your input and you have the ultimate output, and you want people to go from here to there without you explicitly writing the code, as we said. Now, the way it's done under the hood with TensorFlow is that TensorFlow sets up basically your model, or basically your neural network specifically, and then it does that as a graph. And so you have multiple pieces that are connected to each other, and as you probably can see here, you've got inputs, and in this case you've got vectors, and you also have operations. So you have the add, for example, operation. You also have the multiplication operation, or you have the subtraction operation as well. And all of these things, so you've got operations, and you've got also the input details and the output, they're all represented as nodes in a graph. And so TensorFlow is really good when it comes to representing that kind of form, that kind of model. Now, the reason we do that is that under the hood, what we really do is using a lot of methodologies like gradient descent and other stuff as well that have to do with math. In case you're not fluent in that space, you'll be able to basically get the optimal values for your neural network, in that case the optimal values for the weights of your graph. And so to first start, TensorFlow has to build a graph that represents your logic of the model. So this is what TensorFlow does under the hood. It's just basically a graph engine, a graph-based engine that creates nodes for you, and then it connects it all together so you can benefit by using different methodologies that work on the idea of graphs. Now, TensorFlow itself as a library is only a single piece of the whole ecosystem. TensorFlow has grown into a larger form. So back in the day, we only had TensorFlow, but now we have TensorFlow as a full-fledged solution, just like what I said. For example, so in TensorFlow, you have multiple ways to work with the system. You either work in a high level, let's say, in a high level API, where you can just set up those nodes, as if you're putting Lego parts, and we call them layers. So if you're dealing with machine learning, you put layers and then you connect them all together, and then those layers connect with each other and they do the math in a very nice fashion. Now, if you're hardcore and you want to go, down the rabbit hole, let's say, and you want to go one level lower, you can also work with building the layers themselves. So you don't have to use ready-made layers. So for example, we have layers in machine learning that are, for example, dense. We have, a lot of cool stuff that we could just plug and play. But in order to build a custom model that doesn't follow the regular, dense form for neural networks, you can also build layers on your own if you wanted to. And with TensorFlow, you can also do that. So you have the ability to subclass some of those main classes within TensorFlow. And then from that, you can, customize exactly what happens when you're talking about the gradient descent computation, if you're talking about how those layers are connected, and how you train those, weights inside. So you get to have that sort of a thing as well. And it's fair to say that TensorFlow 2.0 now is a complete solution. So back in the day, we had the problem with TensorFlow, like in the earlier versions, where you have to basically set up the whole model and then you can debug if you wanted to. But now we have this thing that we call eager execution, which means you have a Pythonic, let's say, a nicer way to deal with TensorFlow if you wanted to debug, as if you're just writing a regular program. And then you can also annotate some of those functions that you write in order to be, computed as a graph for TensorFlow. So you have that flexibility to exactly tell which parts you want to compile, which parts you want to also, basically keep them for debugging, for real-time debugging, aka the eager execution model. And so now TensorFlow 2.0 has borrowed a lot from this machine learning library that we call Keras. In fact, Keras now is a complete namespace under the TensorFlow 2 system. So with Keras, you've got so many cool things. You can just work in a very high level, way without really focusing on the technical details of the gradient descent and how these models, basically do the training under the hood. So there's a lot of math, a lot of methodologies, a lot of algorithms that you don't have to put your hands on if you're trying to figure out how to deal with TensorFlow. So TensorFlow is suited to multiple layers of expertise. You can be a very, let's say, you can be a beginner and you can work with the high level API, but if you're an advanced user, you want to build custom stuff, really custom models, different layers, different architectures that are crazy, you can go down, just like what we said, you can go down multiple layers and then tweak the operation however you want. And so Keras is a power horse that's being used with TensorFlow. We also have other namespaces that can allow you to ingest data and work with it in a parallel form as well. Now, my personal favorite is with TensorFlow, it is very easy now to target different hardware if you wanted to. So back in the day, if we wanted to do machine learning, we'll probably train against CPUs. But now you've got GPUs and you've got also tensor processing units by Google. And you have different devices and you can even build custom processors, custom microprocessors if you wanted to. And by building a distribution strategy, or you can also use a ready-made one just like those here, you'll be able to take your training process, your whole training basically the whole training process for your model, it can be offloaded to those hardware devices without you changing any, line of code. So this is really beautiful because it allows you to really capitalize on those devices and those things that are available without you reinventing the wheel or building any custom setup for yourself. So distribution strategies are really cool, and it's one of the things that are available with TensorFlow. Now, TensorBoard is a debugging solution that works hand in hand with TensorFlow. It's actually part of TensorFlow as well, and allows you to see your model performance as you're building it, the kind of accuracy that you have, the validation, accuracy, and the basically all the other metrics that we have and we enjoy in TensorFlow. And machine learning is always they're all available in TensorBoard in a graphical form. So it's so cool and easy to see things in action rather than just hear about them. Also, with TensorFlow, we have the ability to save our models, in a compact form that has the weights and the architecture itself. Remember, when we say the architecture, we talk about how those nodes are, talking to each other, how they're formed. And you also have now a repository called TensorFlow Hub that allows it to borrow things if you wanted to, and you can build on top of other people's work. Now, TensorFlow serving is also their solution for the cloud if you want to serve your model and you want to really rely on their infrastructure for basically the API wrapping and everything else. So it keeps your productionizing your production pipeline much easier to work with. Now, TensorFlow Lite is one also of my favorite, which is the ability to build your model and then export it to work either on a microcontroller or like an IoT device of some sort, like the Raspberry Pi, or you can also put it on an Android device or an iOS. Now, you might ask yourself, now why would I do that? The reason you want to go for this is when you want to have your machine learning pipeline working in an offline environment. Not everyone enjoys the luxury of the internet. So imagine you're working in a rural place, or you're working in a, let's say, in an oil field somewhere else, really far, and you don't have coverage. And so for those use cases where you're going to have to rely on machine learning, it is so cool to have the whole TensorFlow ecosystem living on your phone, so you don't rely on the cloud if you wanted to do things. Now with TensorFlow, with TensorFlow Lite specifically, you get that chance, and you can also compile your model to work on TensorFlow Lite, and you're going to have a specific model that you can load against your runtime environment, be it an Android, an iOS device, or even a microcontroller. So you can see that even with Arduino if you wanted to. So there's a lot of use cases and tutorials out there that show you how to compile your solution, keep it as a binary, your model, and then load it on the on the Arduino device itself, and you can do that in an IoT device. Pretty cool if you ask me. And just for fun, TensorFlow is also available as a JavaScript library, which means you can use it now on the browser, if you want to build things that are cool in the browser without, relying on different things as well. Cool. So let me show you the source code for TensorFlow. Now, if you go to tensorflow.org, okay, you can go here. And when you go here, you'll be able to check out the whole thing. Now, I want to give you a very small tour in here so you can pick up what's happening. So in TensorFlow, your regular Joe is going to go for Get Started with TensorFlow. This is where you see all the tutorials, and you can probably see it here. And it's so cool. With TensorFlow, it's just importing the library, and you get Keras by default out of the box under TensorFlow. And it's just, you can even have sample data that you can work with and experiment with. And as you probably can see, we have so many layers here. We have the flat and the dense, the dropout. All of these things are the things that you'll learn when you're dealing with machine learning. But it's so cool that you can put them all together as if you're building, Lego pieces, and you're putting them all against each other. With a couple of instructions, you can compile your solution, and you can train your solution, you can evaluate it, and you can put it in production. Now, TensorFlow works really well with Jupyter Notebook, and you can probably see that. If I click on that button, it's going to run on Colab by Google, which is so cool. Now, on the other hand, if you don't want to go for the beginner kind of source code, you can always go for the expert kind. And that means you can get, you can go really low, and you can build your model, and in that model you can have multiple layers however you want. You can also compute the gradients on your own. You can compute them however you want, and you can also build layers if you want. So this is here, like here, we're just building a model that we can rely, on in our use cases. However, you can also build layers. So anything that sounds like you can basically build an equivalent to this layer, the dense layer or the dropout, and then you can use it within the sequential model where you can put layers next to each other. So this sort of API, the low-level APIs are very, very helpful whenever you do this. And you have so many use cases. So you've got your regular setup of building a neural network on, you've got the MNIST data set, for example, and you can really go hard whenever whenever you want to work with machine learning. So it's very cool for different kinds of people, whether you're dealing with basic tasks or if you really want to go so deep that you want to build your own model and everything else. So everything is here. We're not going to cover that. This is a different course on its own. We're mostly interested in the source code and how to build the solution. Now, when you go here, you can see the whole functionalities of TensorFlow. We're mostly interested in the API itself. So when you go to the API here, you will find that the API for TensorFlow, and you can probably see that it has so many versions as well. If you go here, you will find that TensorFlow has multiple language support. So Python is by far the most popular one, and you have all of these namespaces in here that we normally rely on when we're building our models. And this is how you can build that basically in Python. However, it's fair to say that TensorFlow is actually built on C++, in case you did not know that. So C++ is the language that allows us to connect, let's say, in any performant way, with the hardware, so we can, get things to run much faster, to get better results. Like when I say better, I mean much faster. And so all of these are actually the namespaces that you can rely on if you're dealing with the C++. Now, a regular user is not going to be using the C++ API, and that is very easy to answer, because if you're dealing with C++, you have to go really low, and you're going to have to work with memory. You're going to have to deal with a lot of complexities spanning, destruction of objects, deconstruction of objects, and C++ is not for the faint-hearted, basically, and you all know that. Now, Python is the main language that the community supports, and it has a lot of libraries and so many cool things that you can rely on if you're starting. But however, it is fair to say that the C++ is the core workhorse that gets TensorFlow to work. Now, if you want to get the source code, it's actually here on GitHub, and it's TensorFlow, and everything is in here. Now, TensorFlow allows you to get, the whole thing here to build, and you have multiple versions. So you've got TensorFlow, for example, that runs on the CPU, and you also get to work with TensorFlow that works against your GPU as well. So all of these things are actually here within the repo. And let me get you a small tour here so you can understand how to read it. Now, TensorFlow is here, and the main source code is available under this directory, and you will find so many things. So let's start with that one first. So C has the C API, and we're going to see it in action. As you can probably see here, I have a demo. So the C API allows people to work with the TensorFlow engine, but in a very low level fashion, and you get all of this nice C code. I'm not sure if I can call it nice for the faint-hearted, but basically the C code is available here, and it's not only that it's available here to serve the TensorFlow stack itself, but you also as a user can basically connect, and when I say connect, I mean rely on the C API to build your own applications also if you want. Okay, and we're going to see a demo there, but I wanted to show you that the code is actually here. Okay, and we have different toolsets that cover the compiler itself. So remember, TensorFlow builds your graph, and it compiles your graph in a form that can be read in an execution engine on the target device. And I'm going to cover that in my slides in a second, but I wanted to get you a tour on the source code first. It has also Java bindings, so you're going to find the source code here in order to understand how Java can connect to the C++ side, and this is basically the part where we connect to the C++ side. It's called the JNI, or Java Native Interface, if you're coming from that world, that Java world. Okay, so this is basically the glue code that basically binds the Java high-level code with the C++ low-level code. Okay? All right, so this is basically where you have Java as well. You have support for Go, JavaScript, the light support, and then Python, where you have the majority of everything in here. So you've got Keras support, for example. So under Keras, you've got, let's say, layers, and then, everything is in here. It's so cool to have the source code in one place. So let's say pooling, for example. So as you can probably see, the pooling code is here. and this is the Python code that you normally rely on if you're building anything, you know, within the TensorFlow space in the Python, again, ecosystem. And you have code for security and everything else, but one thing that I want to really capitalize on is the idea of kernels, and we're going to get to that in a second, but I just wanted to get you a graph, you know, of the whole thing here first before we continue the discussion. Okay, so back to our slides. So just remember that the code is available on TensorFlow, on TensorFlow's repository on GitHub, just like what I took, just like what I've showed you now. Okay, now for the architecture. You see, TensorFlow is a stack of solutions, a stack of, you know, multiple source code bases. The one that you normally rely on if you're building a machine learning model, if you're a machine learning engineer, is the Python front end. So Python itself, you know, you've got layers, you've got estimators if you're working with estimators as well, which are a high level abstraction for your model that can scale much better on the, you know, basically on parallel infrastructure. You got Keras models, your data sets, your everything that you work on Python basically covers here. Now, it's fair to say that C++ and Java and Go have the same ability because they all work on the TensorFlow execution engine. Now, TensorFlow itself has two parts. You got a part where you compile, basically the compiler that compiles your model basically in a form that you can then deploy somewhere else. And so that compilation process of building the graph itself, training the graph, it's all basically, this is what we call the first part. The second part is the inferencing aspect. So when you build a model, you will ultimately need to go and use that model. Now, to use that model, you need to inference the model, meaning you give it input, and that graph is going to be executed with all the weights that we have worked on, you know, in the training process, so you can get to the output that you want. So imagine you're doing a supervised classification model. So your image is going to be fed into your model, and then by the very end, you're going to have one output that says, or if you have two nodes, cat or a dog. It's going to be one of those. So all of these, you know, mathematical workloads are in the middle, and in the very end, you get to that goal. So that TensorFlow execution engine is the one responsible for actually executing that workload. Okay, so this is what you get. So all of these stacks, all these languages are actually the very end working against that execution engine. Now, it's fair to say that the execution engine is not a standard solution. So depending on your target hardware, you have multiple distributed execution engines. For example, if you're working against your CPU, that TensorFlow execution engine is going to be run on the CPU. And you have a different, you know, either a library or a specific code baseline that works on different hardware as well. So when you run the TensorFlow supported version for the GPUs, you're going to have the ability to inference on the GPUs. This is why it's much faster to have that sort of support, because the execution engine can now target the specific cool features of the GPU, like if you have SIMD engines or vector engines within the hardware itself to speed things up. And if you have Android as well or iOS, when you have different support for tensor, let's say specific machine learning cores within, you know, the hardware, you can also use that. And we also have a compilation infrastructure called XLA that allows you to do really cool things of compiling into that target device that you build and then basically release your code for it. So the stack is not really that complicated, but we have layers and layers of code, you know, that allow us to get to that level of, you know, basically performance that you get with TensorFlow. So I want to show you some of the languages and the bindings that we have. So as I showed you, so C++ is a core language in TensorFlow. Believe it or not, it's not going to go away anytime soon. And C also has an API. Now this is cool because we can have, you know, our own code binding to C. And you also have Go, just like what I said. So let me take you through here. And so I have a solution, but before I go there, I want to show you on their website here. If you go to tensorflow.org and you go to install, you're gonna find that you have a tab here, not really a tab, but a small segment that says the kind of languages that are supported. Now, if you go to C, for example, you'll find that TensorFlow provides a C API that you can use if you want to build things and, you know, do the work on your own. And when you download here, you will have the libraries that correspond to the support that you want. So if Windows, so I'm using Windows obviously, so I'm going to use the CPU, you know, library that allows me to build an application against the TensorFlow library to work on the CPU. Now, when I download the files, and you can also get it in different forms, this is a sample code that we can use in C, of course, after we set up our environment with the compiler and everything else. Now, I've done that, and I actually have a demo here. Let me just zoom in. So this is a basic code that I wrote, and it's actually just copy-paste the one that you've seen on the website. However, the small thing that I've done here is that, let me show you here. If I go here to my demo, I've got the TensorFlow CPU files downloaded already and extracted. And now if I go here, I will have an include folder that has TensorFlow, C, and you're gonna find the C API listed in here, the headers of course in C++, and the eager execution is here as well. And when I go there, you're gonna find the library itself. So the library, as you can probably see, 145 megs. The library is here. So this allows me to switch to my Visual Studio environment, and then in the project settings here, I'm gonna go for the C++ code, and I'm gonna basically just put the path here, okay, to the include folder, and then I'm gonna go for the library path as well. So this is all standard C++ machinery, you know, and basically instructions. So if you're coming from that space, this is all straightforward. But if you're just coming from Python, just think about it as, you know, a regular setup if you wanna basically integrate with a different library. So we target the lib folder, and then we tell Visual Studio to specifically use tensorflow.lib, which is the file that I just showed you in here. So this file. Okay, so if we go here now, and I go to my code, and I do this, and I say build. So we're building, and I actually already built this, so let me just do something else. Let's say, we just say hi, okay? So when I build the application, it's building now, and believe it or not, it works. Now if I run the application, hi from TensorFlow to C API, okay? And I can basically get that here, and you see the application actually runs. So I can run the application, okay? And I'm connecting to the TensorFlow ecosystem, you know, using the C API. So this is pretty cool. Now, when you go here and you want to explore the TensorFlow C API, just like what we said, there's a lot of things that you can use. But for now, we're using the most, like the simplest function ever, which is the TF version. And as you probably can see, the function is here. However, it has extern here next to it, which means the binary itself, this is basically a library, a dynamic library. So the implementation is not embedded within the header files itself, and there's no corresponding implementation for this function. And you can see the code, and let me just show you 1 second. Okay, so that code is something that you're gonna find in this DLL file. So this is a dynamic library, DLL, dynamic link library, and it has all the implementation that you need for TensorFlow to work, okay? So just remember, this is just a proof of concept that you can rely on C and C++ to build your own API, basically bindings. Okay, so this is for TensorFlow, and you can also do that with Go if you're interested. It all has the same concept of basically working with different languages if you want to use that. Now, if I wanted to do something different, I would go for the Windows GPU version, and then I can do the same thing and work with it, so it can work with my NVIDIA chip. Okay, cool. Now, if you're interested, you can go here, by the way, and you can go for the API and explore what you can actually use if you wanted to use it here. Okay, so this is the C++ API, not the C API, which is, let's say, kind of richer than the C API. You are basically now, normally when you're working with this kind of workloads, you're not going to be dealing with the C API most of the time, but it's there for you if you want to build something really, really custom. You're either going to work with C++, or if you're just a machine learning engineer, you're going to work with Python, which is very straightforward. Okay, now it's fair to say that TensorFlow as well allows you to do work with different languages, and one great example of that is the LLVM intermediate representation. So LLVM is a compiler that got so popular, and it's now in competition, let's say, with your popular GCC, your GNU GCC. So if you're coming from the Linux space, you know GNU GCC pretty well. And so LLVM by Chris Latner is a great compiler, and it works in so many different spaces. You can either use it with C++, you can work with it if you want to do, if you're building for a custom hardware, for example, a custom microprocessor, you can also work with LLVM and tweak it a bit in order to do that. Now, the folks in TensorFlow have used that in order to target JavaScript. This is why you have the support for JavaScript in TensorFlow. And let me show you that, okay, before we just go forward. Now, if you have the API here, you got TensorFlow.js, and it's almost the same thing. It's basically working with the TensorFlow, ecosystem with the library and any nicer, in an easier form that can be done, can be used within the browser. So you have your basic classes here: tensor, scalar, multiple functions as well. Let's see, print, for example. Very cool things to work with, and you can try it in the browser as well if you want. Yep, so you can put that in here, and you can go ahead and experiment if you want. So it's so cool, straightforward, and you can experiment all in the browser. The power of JavaScript, yeah? Okay, so coming back to the slides again, this is TensorFlow. I wanted to tell you something about the machinery of TensorFlow. So TensorFlow relies on a concept called kernels. And that means you have multiple operations that don't have their implementation within the source code always. Sometimes you want to have a specific implementation depending on the hardware that you have. So the basic operations that we have in TensorFlow can span add and multiply, and all of these operations that we have. And then if you're building a new hardware device, imagine you want to support a new node or a new operation. Now, in order to do that, you can build a kernel. This is what they call a kernel, or an operation in the machine and the space of TensorFlow. Now, if you go to the documentation here, I want to show you. If you go to the advanced, not here, let's see if we have the advanced one. Yeah, custom ops, kernels and gradients. This is where exactly shows you how to build a custom operation that can be supported either by your TensorFlow setup, or even if you want to do it for a custom hardware. Okay, very straight, very cool. And even though it's really an advanced thing, however, TensorFlow really shows you how to do it, and you're going to rely on building a C++ or C++ component that can then be wrapped through Python in order to be used within this realm of Python. But basically, when you want to build a custom operation, you want to build that operation in C++ first. And I'm not sure if we have support for TypeScript or anything else, but as far as I know, you need to build your let me just double check. Yeah, so this is basically for JavaScript. Yes, if we were in the C++ space, we're gonna have the same thing. So sorry, not JS, we're talking about your regular setup. Okay, where's the guy? Okay, yeah, let's go here. Let's go for tutorials. There you go, and then we can go for guide, custom. Yeah, so we have everything in here. We create an op, for example. There you go. Okay, so this is how you actually write an operation, and you also have to register the operation. So imagine you're doing an operation called zero out that tells you exactly how to deal with the tensor. You build it like that, and then you do the implementation. Remember, this is very specific to your target environment, to your target hardware itself, and then this is an example where you do a GPU kernels that run on the GPUs, okay? And you're gonna find, and I'm sure, a place where you rely on CUDA. There you go. So if you're using CUDA, you're gonna rely on the CUDA specifics here so you can build the application or this specific library to work there. Cool. So this is basically how we go about building things like, you know, the operations, those custom ones. Okay. So just remember, TensorFlow is a graph engine. You have multiple operations in that fashion, and then you are feeding the information to those operations. Now we have standard ones: multiplication, add, divide, print. So in fact, if you go to the website and you look for the operations in TensorFlow, you're going to find them all listed in one place. However, if you want to build a custom one, if you have the really urge, if you have a very genuine, let's say, a custom requirement to build a specific node, well, then you can go to the specific tutorials that I showed you where you can build something custom. But it's very unlikely that you're going to go there. Let me show you another thing which is pretty important to the source code of TensorFlow. Now, in TensorFlow, if you go here, you're going to find that in every place you go, in every folder, you're going to find this file, build. Now, this build is a component, and it's a dependency for an app, not an application, for an infrastructure that we call Bazel. So Bazel is basically a build system, and we use it heavily within TensorFlow. Now you might ask yourself, now why would I go there? Now if you build complicated projects that have a lot of dependencies that can target cross-platform environments, imagine you're building something for Linux or something for Windows or something for Mac, you don't want to maintain multiple code bases. So the way to go about it is that you build your source code base only once, and this is the case here. As you can probably see, we build the code base only once, and then Bazel itself is going to be able to help you to target multiple platforms, multiple platforms depending on your requirements and the specifics that you put. So Bazel is very similar to CMake, if you have ever used CMake, and CMake is a very reputable solution. So CMake is always used for custom applications that are cross-platform, and so Bazel is a different flavor, and it's heavily supported by Google because they use it a lot. And so it shows you here how to build, regular C++ applications, and you embed the support for Bazel. And just remember, these are the specifics for Bazel, and then you can basically just say Bazel build, and it's gonna build your solution, making sure that your dependencies are done well. So if you have a very complicated solution with multiple dependencies and some crazy graph, that represent your dependencies, you don't have to maintain it on your own. You can just basically rely on Bazel to do all the setup, to build what is necessary first, and then build on top of it. Now TensorFlow relies heavily on that, and each folder in here, if you go to any TensorFlow folder, you're going to find that it really depends on Bazel, like basically all in all. So even if you go for TensorFlow, for example, let me show you how to do that here. Let me take you to tutorials here. Let's see. If you go to guides, then you go, let's see if we have it here. Okay, 1 second. It should be, I'm just right here. Compile TensorFlow. There's a page that I don't really remember where that is. TensorFlow. Okay. Let me just find it. No, not here, sorry. Build from source. Yes. There you go. Okay. So when you try to build from source, sorry, I missed that. You come here, and let's go, for example, on Windows, just for the sake of example. You will download all these dependencies, and then you have MySys, which is a specific ecosystem that allows you to run Linux environment, Linux commands, like a minified environment. And then you have specific stuff that you need to install for Visual Studio, because remember, you're going to use Visual Studio heavily, and you have to use Bazel as well. And by the end of it, you will use Bazel definitely. So this is the core item here. As you can probably see, we're building the pip package for the CPU. However, if you want to embed the GPU support, you have CUDA GPU, and then the whole thing is going to be built for you, and you're going to have a small package, a wheel package that you can then use with Python. So a really great environment that relies on Bazel to get you to really let you escape the headache if you wanted to. So there you have it. If you want to build everything from scratch, or if you want to build that on Linux as well, if you're a Linux hardcore user just like myself, everything is in here. Okay, so this is for Bazel, and I wanted just to show you how Bazel is really core to the whole operation. So we've also seen the C++ wrapper. Now I wanted to do the compilation, however the compilation might take a while, but I wanted to show you the commands, and this is exactly what I showed you on that page. So if you wanted to go, just make sure you download the source code through GitHub, and it's going to be a very cool experience for you guys. Now I want to leave you there. I don't want to go very deep with TensorFlow. It's a very fantastic library / ecosystem. Just remember, in the race of business, data can either make or break your business. So if you have any business, make sure you really work hard to build the data infrastructure from the get-go, so you don't have any trouble down the road. And if you are excited about these things, you can also see my videos on YouTube. I have a YouTube channel, by the way, and I cover a lot of aspects in machine learning, AI, reverse engineering, security, open banking, a lot of stuff. So you can just write Ameen on the search bar. And yeah, there you have it. I really hope that you enjoyed this. It's very cool to be here, and I'm sure that you guys are going to really enjoy this session. Whenever you progress in TensorFlow, this is going to be very cool and interesting for you guys. So yeah, there you have it. You can always reach out to me if you want at ameen@altajer.com, and you can also have INFINITEWARE.com if you're interested in the solutions that we have. Now, I might not have the ability to respond to questions here on YouTube, but please write me any question on @AmeenAltajer, whether we're talking about Twitter or Facebook or Instagram, whatever you're comfortable with. I'm also available at linkedin.com. Okay, so I'm gonna leave you here. Do machine learning, have fun, and build things responsibly. Okay, have a great day.